Machine learning. You hear that phrase thrown around all the time. But what on earth does it actually mean? Well, it's the tech that's quietly running in the background of your life, making decisions and predictions for you every single day. So today, we're going to pull back the curtain and see how it really works.
Seriously, have you ever thought about it? How does your inbox just know that an email is junk? Or how does Netflix seem to read your mind and suggest the perfect movie for a Friday night? The answer to all of it is machine learning. It's all about teaching computers to learn from data, so we don't have to write code for every single possible scenario. To really get it, let's start with a super simple example.
Okay, let's play a little guessing game. We're going to tackle a very human problem, trying to figure out if someone is going to like a new song. This, right here, is the core of what machine learning is built to do, make smart predictions based on what's happened in the past.
So meet Paul. Paul is a simple guy when it comes to music. He either likes a song or he dislikes it. That's it. No 50 shades of gray. His taste, his past choices, that's our data.
And to keep things nice and easy for us, Paul's entire decision-making process boils down to just two things: the song's tempo, is it relaxed or fast, and its intensity, is it light or is it totally soaring?
Now, when we lay out all of Paul's past choices on a chart like this, something really interesting happens. A pattern just jumps right out at you. You can see a cluster of songs he likes up here, the fast and soaring ones, and down here are the ones he dislikes, the relaxed, light ones. This clear trend is exactly the kind of thing a machine can learn from.
So what happens when a brand new song, let's call it song B, comes along? Uh-oh, look where it lands, right in the middle. It's got a medium tempo, medium intensity, it's in that tricky gray area. So is Paul gonna like it or not? How can we make an educated guess instead of just flipping a coin?
Well, this is where the machine steps in. And it's not magic, it's just a simple, logical process. It uses an algorithm called K nearest neighbors. The K is just a number you pick. In our case, we'll pick 5. So, step 1, it finds the 5 songs on the chart that are closest to our new song B. Step 2, it just counts the votes from those neighbors. And what do we see? 4 of them are likes, and only 1 is a dislike. So step 3 is easy. The machine predicts Paul will like the song. That's it. That's a machine learning algorithm right there in action.
Okay, so we've seen a fun little example of it in action. Now let's zoom out a bit and use that to build a proper definition. Fundamentally, what is machine learning?
This slide, right here, this is the key to the whole thing. In the old world of traditional programming, we humans had to write the rules. We'd tell the computer, if this happens, then do that. You give it rules and data, and it spits out answers. But with machine learning, we completely flip the script. We give the computer the data, and we give it the past answers, like Paul's likes and dislikes, and the machine figures out the rules all by itself.
So if you need the official textbook definition, here it is. Machine learning is a field of AI where systems learn patterns directly from data to make predictions. And the most important part is that last bit. They do it without being explicitly programmed for every single task. They learn and get better on their own.
Now, it turns out there are a few different ways that machines can learn. The first, and probably the most common, is called supervised learning. The best way to think about this is like a student learning with a teacher who already has the answer key.
Here's a perfect analogy for you. An election exit poll. You've got all this feedback coming in from thousands of voters. That's your input data. And crucially, you know who they actually voted for. That's your output, your correct answer. The goal is to train a model that can look at this early data and predict the final election result.
And that, right there, is the heart of supervised learning. The machine is trained on data that is already labeled with the right answer. Remember Paul's song list with likes and dislikes? That was labeled data. The machine's job is to figure out the relationship between the inputs and those known outputs.
And you see this kind of learning everywhere. Think about predicting house prices. A model gets fed a ton of data about past home sales, square footage, number of bedrooms, location, along with the final sale price. It learns the patterns. Spam detection, fraud detection, even weather prediction, it's all the same idea.
Okay, but what happens if you don't have an answer key? What if your data is just a big, jumbled mess with no labels? Well, that brings us to our second type, unsupervised learning. This is where the machine has to figure things out all on its own.
A really fun way to think about this is inspired by the movie PK. You know, an alien lands on Earth and has zero context for anything. He doesn't have a guide. So what does he do? He just starts grouping things based on what he observes. These people all wear similar clothes, so maybe they're a group. These vehicles all move on rails. He's discovering the structure of our world without a teacher.
And that is exactly what unsupervised learning does. You give the algorithm a whole bunch of unlabeled data, and it sifts through it, looking for natural clusters or hidden patterns. It's not about predicting one right answer, it's about discovering the inherent structure in the data itself.
This is incredibly useful for things like customer segmentation. A company can find natural groupings of its customers without having any preconceived notions of who they are. It's also used to automatically group similar news stories together from around the web or to spot weird activity on a computer network that doesn't look like anything we've seen before.
All right, on to our third and final type, reinforcement learning. Now, this one is really cool. It's all about learning from trial and error, a lot like how you or I or even an animal learns by interacting with the world.
The whole idea is built around a simple feedback loop. You have an agent, that could be a robot or it could be a piece of software. The agent performs an action in its environment. If that action leads to a good outcome, it gets a reward, a digital treat. If it's a bad outcome, it gets a penalty. And over millions of trials, it develops a strategy, a policy, to get the most rewards possible.
So reinforcement learning isn't about looking at a static dataset with labels. It's about learning the best way to behave in a dynamic, changing environment based purely on feedback from its own actions. It's learning by doing.
And this is where we see some of the most mind-blowing applications of AI. A robot that teaches itself how to walk, an AI that masters incredibly complex games like chess or Go, or an autonomous car learning to navigate a busy intersection. These all rely heavily on reinforcement learning. So we've covered the what and the how, the three main types of machine learning. But the biggest takeaway here is that this isn't just theory from a textbook. This stuff is already deeply woven into the services you use every single day.
When you go to get an Uber and the price is surging? Yep, that's a supervised learning model predicting supply and demand in real time. Those recommendations on Netflix that are just a little too perfect, that's an unsupervised learning algorithm that's found a cluster of people with tastes just like yours.
Ever get a text from your bank asking if you just bought something weird? That's another great example of unsupervised learning, a model that knows your normal spending habits and flags something that didn't fit the pattern. And of course, self-driving cars. They're a mix of everything, really, but they rely heavily on reinforcement learning to figure out the best, safest driving policies through millions of miles of simulated trial and error.
So from predicting which song you'll like to actually driving our cars, machine learning is totally changing our world by letting computers learn from experience. And that really just leaves us with one massive question to think about. As these machines get better and better at learning, what should we teach them to do next?